For this video, we will be talking about inverses, how to find them, what they are, and how to graph them. So an inverse of a function is almost like you're undoing something. And you've seen this before when you had something like cosine of theta is equal to 5/11. In order for you to undo the cosine function, you take the cosine inverse of both sides. So cosine inverse and cosine inverse. So then theta is equal to cosine inverse of 5/11. There. At its very core, the very basics of an inverse is to switch the x and the y values. So let's say you have a function which has the point 3,11. You can find an inverse function, and your new point is going to be 11/3. Okay. So these 2 points, if this is on the original, then this is on the inverse function. Now, it's really easy to find points of inverse. So if I give you a point 1,20, give me the inverse of that point. Oh, that's going to be 20,1. But the hard part is to find an actual function where you can get an inverse all the time. So, and I'll explain more when we have the graph, but to find an inverse, so let's say we have y is equal to 2x minus 1. All we have to do is two things. Switch the x and y, and then isolate the new y. So if we look over here, okay, we switch the x's and the y, so x is equal to 2y minus 1. Negative 2y is equal to negative x minus 1. Y is equal to 1/2x plus 1/2. This is my original function, and this is my inverse function. And let's go ahead and see if what I actually said was true about the numbers flipping. I'm going to pick a random point that exists on here, maybe 3,5. Okay, if I plug in 3, I get 5. If I plug in 5 over here, if you do the math, that becomes 5/2 plus half, which is 6/2, which is 3. So if I have 3/5 here, and if I plug in 5, I get 5/3, 5,3. So we found an inverse function just by using these two things. Y is equal to the square root of x minus 1. First thing I'm going to do is I'm going to switch the x and the y. I'm going to square both sides, so x squared is equal to y minus 1. And then x squared plus 1 is equal to y, which is the same thing as, y is equal to x squared plus 1. There. And just to prove that this is actually inverse, a point that exists on the original is, let's say, 10,3. So this 3,10 should exist over here, and if you do the math, yes, it does. Okay. Remember that it all boils down to two things. Switch the x and the y, and then isolate the new y. Okay. Let's do something here again. Y is equal to x over 2x minus 3. So x is equal to y over 2y minus 3. I'm going to multiply both sides by 2y minus 3. Because these cancel out, I have 2xy minus 3x is equal to y. Let's switch these two. So 2xy minus y is equal to positive 3x. Divide both, or factor y out of both sides, so y, and then 2x minus 1 is equal to 3x. And divide both sides by 2x minus 1, so y is equal to 3x all the way over 2x minus 1. If I plug in 1, what do I get? I get negative 1. And then, if I plug in negative 1, I get positive 1. These two are inverses of each other. So what's important about this is, how does this tie into transformations? Well, okay, we can ignore that. This is the order of all the transformations that we have. First to the inverse, then absolute values, which we haven't really touched on and we don't really need to right now, reflections, compressions, and expansions, and then finally translations. So let's say we have the point 3, negative 1 as the original. Okay. Let's see what's going on over here. Now the sign for an inverse is this, so we're going to use that. First thing is an inverse. So 3, negative 1 becomes negative 1, 3. Next, we have any sort of, we don't have absolute values, we don't have reflections. Oh, compressions and expansions, we have a vertical expansion by 2. So times all the y values by 2, so it's negative 1, 6. Then we're left with move right by 4 and move up by 1. If we move right by 4, we add 4 over here, so that becomes 3, 6. And we add 1 to the y, so that becomes 3, 7. Okay. Let's do one more. What happens over here? 6, 3 is on y is equal to f of x. What is the new point on y is equal to negative 2, f of 3 of x plus 5 minus 7. So, let's do 6, 3 is the original. We do have a reflection. So a reflection in the y, in a vertical reflection means this point becomes 6, negative 3. We times 2 then, so it's 6, negative 6. This is the same thing as saying y is equal to negative 2 f of x plus 5 over 1 over 3 minus 7. We've done the negative, we've done the 2. We have to times the x value by 1 over 3, so that becomes 2, negative 6. Move to the left by 5. So that's negative 3, negative 6. And move down 7. So that's negative 3, negative 13. All right, so that's the very basics of what you need to know about transformations. We don't have to go through these other ones over here. But next on, we're going to move on to exponentials and logarithms.